Okay, determine the SI unit for mu if a stretched string forms a first harmonic where frequency f obey the following relation. So the relation given in the question is frequency equals to 1 over 2 length square root tension over mu. So we need to find for the SI unit for mu. So you have this relation. So the first thing you need to do is to rearrange this equation until you get mu as the subject. So okay, let's start rearrange this equation. So when you rearrange this equation, you will get 2 length frequency equals to square root of tension over mu. Now we need to get rid of the square root because we want mu. So when you get rid, you square both sides. So when you square both sides, you can get rid of the square root. So now you have 4 length square frequency square equals to tension over mu. So as we need to make mu as the subject, you will get tension over 4 length square f square. So now we need to determine the SI unit for mu. As we know, tension is force. What is the SI unit for force? The SI unit for force is kg meter per second square. Then divided by, what is the SI unit for length? It is meter. But you have square here, so it will become meter square. What is the SI unit for frequency? It is per second. So you have squared, so it becomes s power of -2. Now you can get rid of s -2 and -2, and you will be left with kg m -1. You have 1 here, 1 minus 2 is -1. So therefore SI unit for mu is kg m -1. The answer is D. Okay, an object initially at rest. Okay, first, to tackle this kind of question, it's better for us to draw. So let's draw. So you have an object. The object is at rest. So when the object is at rest, what is the velocity? The initial velocity is 0 because it is at rest. Then it moves in the positive x direction. So this is positive x direction at a uniform acceleration of 2 meter per second squared. So the acceleration is 2 meter per second squared until it reach a velocity of 4 meter per second. Okay, then the object travel at constant velocity for the next 2 seconds. So for the next 2 seconds, it travels at constant velocity. So if you say constant velocity, it's still 4 meter per second. When you say constant velocity, the acceleration is 0. Then the object decelerated uniformly at 2 meter per second square. So decelerated means it is negative acceleration. So it becomes -2 meter per second squared until the object stops. So when the object stops, it's not moving, so the velocity is 0. Okay, now you have how many situations? 1, 2, 3. Okay, finally, okay, now it says calculate the total time for the whole journey of the object. Okay, how are you going to tackle this question? So we look one by one. We're going to look at the first one. So you have u, you have v, and you have the acceleration. So how can you find the t? How you find the time? So you can use the formula v equals to u plus at. V is 4 meter per second, u is 0, acceleration is 2, and time, we are going to look for it, and you will get time 2 seconds. So for number 1, for the first situation you are done, and for the second situation you are done as well, because we already have the time, which is 2 seconds. So now let's look at the third situation, which we use the same formula, v equals to u plus at. the final velocity is 0, the initial one is 4, and the acceleration is -2 because it's decelerated, and time. So you will get your time 2 seconds as well. So now we need to find the total time taken, right? So you have 2 plus 2 and plus 2. Total time taken for the whole journey is 2 plus 2 plus 2, which will give you 6 seconds.
Okay, so next up is question number 3. And they say Ajar releases a stone from the top of a building with the height of a building is 10 meters. So we have a building here with the height of 10 meters. Okay, the height of the building is 10 meters. And then the stone is released from the top of a building. So the stone is released. Okay, what is the speed of a stone at 2-meter height from the ground? Okay, so we assume 2 meters is here. So the stone would go down. So they want to know what is the speed here. Okay, what is the speed here? And then we know since the stone is released, so the u initial or the initial velocity is 0. Okay, they want us to find the final velocity, and here we are using the concept of free fall motion, where we know our acceleration due to gravity equals to 9.81, negative 9.81, or g. Okay, or negative g. And then we also can find our displacement, which is distance from the place where it's released until the point that we want. So the distance here would be 8 meters. Okay, but since the stone is moving downwards, so our displacement or our s would be negative 8 meters. Okay, so from this information, we can use the formula v squared equals to u squared minus 2gs. Okay, equation for free fall motion, where our v squared is what we are looking for. Our u squared would be 0 squared minus 2, and g would be 9.81, and our displacement would be negative 8. Okay, so we get v squared equals to 156.96, and v would our final velocity at 2 meters above the ground would be 12.53 meters per second. Okay, so our answer would be C. Okay, so that's for question number 3. Question number 4, they say an army jet moving with a constant speed 150 meters per second horizontally. Okay, so we have an army jet, which is moving horizontally with an initial velocity of 150 meters per second. Okay, so we know they're talking about horizontally here, and the bomb drops vertically. So when there's vertical and horizontal component movement involved, we know this is a projectile motion. So automatically here we can label it as ux. Okay, initial speed in the x component. The bomb drops and it lands forward on the ground at 750 meters. Okay, so the keyword here is it lands forward. Okay, so that means the bomb drops like this. Okay, where we have x and y component displacement, and then it lands forward with a displacement of 750 meters. Okay, so this is our x, the 750 meters. So how far it landed is 750 meters. So that's why this is our displacement in the x component, and this is our initial velocity also in the x component. Okay, so by ignoring the air resistance, the height of the jet is, so they want the height of the jet. Okay, so the height, since the bomb lands on the ground, so our displacement in the y component will also be the height of the jet. Okay, and then we recall from projectile motion two very important concepts. Okay, the first concept is we have we know in the x component there is no acceleration. So acceleration in the x component equals to 0. So from this concept, and then we substitute ax equals to 0 into the three formulas, kinematic formulas. So we get the first equation to be Vx is always equals to Ux. Since there is no displacement, final velocity is always equals to initial velocity. And our second equation would be where Sx or displacement horizontal range is Ux t. So this is the two equation for the x component. Okay, this is for the x component. And then for the y component, we know ay equals to negative g. So the equation that we will get for the y component, that would be 3. The first one is vy equals to uy minus gt. Second one would be sy equals to uyt minus half gt squared. And third one would be vy squared equals to uy squared minus 2gsy. Okay, so this would be for the y component. So these are the equations that we have for projectile motion. So we know it's already given ux. The question have already given us ux and sx. So we have displacement in the x component and we also have ux. So for the first part, we find the time taken for the motion first. So sx equals to uxt, where sx is 750, ux is 150, and t. So t would be equals to 5 seconds. Okay, and then so we've already known t. So next we want to find for sy. Based on what we have, we only have t, and we know uy equals to 0 since it was moving initially only in the x component. So we know uy equals to 0. Okay, so we can use equation number 2 to find sy. Okay, we can use equation number 2 to find sy. We cannot use equation number 3 because we don't know vy. Okay, we don't know vy. So we cannot use this one. We cannot use equation number 1 because it does not have sy what we're looking for. So we use equation number 2. So the second part is sy equals to uyt minus half gt squared. Okay, sy is what we're looking for. We know uy is equals to 0. So our time is 5 seconds minus 1 over 2. G is 9.81 and our time 5 seconds squared. Okay, so we will get the answer to be 122.63 meters negative. Okay, so why did we get negative? Because we know the bomb land is going downwards, so we get our sy to be negative. But the question wants what is the height of the jet. So for the height of the jet, we only want the distance from the ground, so it will be positive. Okay, so the height of the jet will be positive 122.63. So the answer is C. Okay, so that's for question number 4.
Now, let's discuss question number 5. A 1500 kilogram Peugeot car is traveling at 16.67 meter per second and accelerate to 30.56 meter per second for 2 minutes. Calculate the impulse of the car. Now, the first thing we need to do is we need to extract the information given. So here the mass given is 1500 kilogram, and then the initial velocity u is equal to 16.67 meter per second, and the final velocity is 30.56 meter per second, right? And the time given is 2 minutes, and 2 minutes is also equal to 120 seconds. Okay, we know that impulse, capital J, is equal to the force times the time. And also, impulse is also the change in momentum, delta P, or momentum is mu, or change in delta P is mv minus mu. Now, so look at the information that we have. We have mass, we have initial velocity, and we have the final velocity. So we can use this equation to find the impulse. So J is equal to mv minus mu, where this time the mass is not changing, so we can factorize the mass. So mass in bracket v minus u, and then we substitute 1500, then in bracket 30.56 minus 16.67, we will get 2.08 times 10 to the power of 4 Newton second, and this is answer B. Okay, on to question 6. A bowling ball moved towards a stationary bowling pin. Test your understanding of principle of conservation of momentum by filling in the table 1 below. Okay, so in this table here, it has before collision in Newton per second, in Newton second, and we have after collision also in Newton second. So here, looking at the unit, we know that this is momentum, not the mass or not the velocity. This is the momentum. Okay, so we have the momentum for the bowling ball and also for the bowling pin, and lastly we have the total. And here we have 3 unknown. Okay, so for the first part, number 1 Roman, what is the answer? Okay, we know that this bowling pin, number 1 is for bowling pin before collision. For this bowling pin, it is stationary. Okay, so for a stationary object, the momentum would be 0. So J for bowling pin, or number 1, is equal to 0 Newton second. So look at the option that we have. So this is okay, this is okay, this is okay, but C is not okay. So C is not the answer. Now let's move on to the second one. 2. Okay, number 2. So this is the total. So using the principle of conservation of linear momentum, we know that the total momentum before collision is equal to the total momentum after collision. So for before collision, we only need to total all the momentum that we have. So we have to add the momentum by the bowling ball, which is 50. So plus the momentum of the bowling pin, which here we have found out that it is equal to 0. So this is 0. Therefore, the total momentum before collision is 50 Newton second. So let's look at our options. So this is 50, this is 50, and this is also 50. So we cannot find the final answer yet. Now lastly, the third one is the total momentum after collision. So we have the momentum of the bowling ball, which is 80 Newton second, plus the momentum of the bowling pin, which is negative 30 Newton second. So we have 50 Newton second, which is equal to this one. So therefore, it verifies the law of conservation of linear momentum. And looking at our options, so this is not 50, this is not 50. Therefore, the correct answer is B. Okay, that's all from me. Thank you.
Okay, Assalamualaikum and hi everyone. My name is Madam Shafiqah. So I'm going to discuss question number 7. Okay, so now let's read the question. So we have a 90 kg man stands in an elevator that is moving up at a constant speed 5.0 meter per second. So we have an elevator and this is the man. Alright, and this elevator is moving upward, and V is 5.0 meter per second, and it's constant. Alright, so remember, when it's constant speed means that the acceleration is equal to 0. Okay, so now we want to find the force exerted by the man on the floor. Okay, so that's mean we need to calculate what is the weight. Okay, what is the weight of the man, because weight itu adalah force exerted by him on the floor. Okay, kalau force exerted by him on the floor, it's the weight. Kalau force exerted by floor on him, itu adalah normal. Okay, so now we want to calculate what is W. So where W is equal to mg, and m is equal to 90, and gravity is 9.81. Alright, so finally we got 882.9 Newton. Okay, so this is the answer. So before we proceed to the next question, I want to highlight, for this condition, we can write that the total Fy is equal to 0, because total Fy is equal to ma, but now since V is constant, so the acceleration here is equal to 0 meter per second squared. So initially we have total Fy is equal to ma. So since a is equal to 0, so total Fy is equal to 0. So for this case, total Fy is equal to 0. So in y component, we have normal plus negative w is equal to 0. Alright, so now we can write n is equal to w. Okay, but for this question, so this question asks you to find the force exerted by him on the floor, means that we want to find the weight of the man. Okay, so therefore W is equal to 882.9 Newton. Okay, but if the question asks you to find the normal force, for this case, the normal force, the magnitude of the normal force is equal to W, and it's also equal to 882.9 Newton. Okay? Alright, good. So now, let's proceed to the next question, which is question number 8. Okay, now question number 8, we have two blocks here, which are 70 Newton and 35 Newton, and the blocks are connected by a string as shown in figure. Okay, so if the pulley is light pulley and the frictionless, the magnitude of the acceleration of the 35 Newton block is, so we want to find what is the acceleration. Okay, so the acceleration, the direction of the acceleration is like this. Okay, so when we read the question carefully, it's not mentioned about the surface. Okay, so no coefficient of friction is given, so we consider it a smooth surface. So for the second step, we need to draw the free body diagram for mass 1 and mass 2. I will put this as mass 1 and this is mass 2. Now I want to draw the free body diagram for M1. So we're going to have N. I want to use different color here. So I have N and W1 and also T. Alright, and for the mass 2 we have W2 and also T. So this is the same string and we consider the pulley is a frictionless pulley. Okay, so the tension for the both T are the same. Alright, so now let's move to the equations. We want to write the equation for M1 and M2. Okay, so for mass 1, Okay, so look at here, we have the direction of the acceleration is in x component, so it's moving to the right. Okay, so means that we have total fx1 stand for mass 1 is equal to m1a. So we just have tension in x component, so T is equal to m1a. So now we cannot solve for T and A because we have two unknowns here, so we need another equation from mass 2. So let this as equation number 1. Okay, so for the second one, okay, so this is for mass 2. Okay, so for mass 2, it's moving downward in y component, so I'm going to write total Fy2 because the direction of the motion is in y component. Okay, so total Fy2 is equal to m2a. So now look at here. Okay, don't make mistakes here because W2 is the same direction with the acceleration, so W2 minus T, not T minus W2. W2 minus T. So you need to look at the direction of the arrow. So W2 and A is the same direction, so W2 minus T. Okay, so it's actually W2 plus negative T because T is opposite direction. So we have M2A. So now we're gonna write T. Okay, T is equal to W2 minus M2A. So this is my second equation. So now we can substitute equation 1 into equation number 2. Okay, so it's going to be M1A is equal to W2 minus M2A. Okay, so we want to find A, right? So we rearrange the equation so that it will become M1A plus M2A is equal to W2. As we want to find the acceleration of A, so I will factorize this as A M1 plus M2. Okay, so now A is equal to W2 over, so A is equal to W2 over M1 plus M2. But now we don't have the value of mass 1 and mass 2, so we are given 70 Newton and 35 Newton. It's the value for W1 and W2. Jangan careless ya, jangan terus masukkan 70 dekat M1 and M2. Okay, so this is M1, so W1 is equal to M1G, therefore M1 is equal to W1 over G. So W1 is 70 over 9.81. So mass 1 is equal to 7.14 kg. Okay, while M2 here, so W2 is equal to M2G. M2 is equal to W2 over G, where W2 is 35 Newton over 9.81 and mass 2 is equal to 3.57 kg. Okay, so let's solve for acceleration. Therefore, the acceleration A is equal to W2 over M1 plus M2, and W2 is 35 Newton, M1 is 7.14 kg plus 3.57 kg. Okay, and finally the answer is 3.27 meter per second squared. Okay, so don't forget to like and subscribe channel Physics KMM, and feel free to support me in my channel, which Madam Fika Fiki channel. So you can come and like and subscribe and watch all the videos there. Okay, so see you there. Bye-bye. Assalamualaikum and selamat sejahtera.
Question number 9. A lorry of mass 850 kg accelerates from rest to a velocity of 40 meter per second in 10 seconds. M is 850 kg, U is 0, V 40 meter per second, T is 10 seconds. Calculate the average power for this acceleration at the velocity 40 meter per second. How do we calculate average power? Average power is equal to W divided by T. Okay, W is work done. Work done, what we know from chapter 5, is equal to Fs cos theta. Is this the right equation to use? Is this a viable option? I don't think so, because we don't have any information on displacement, which is the physical quantity that we have in this equation S. Yeah, so we have to look for another equation that's more suitable to solve for average power. So what I know from work done is equal to delta K. This is what we know from work energy theorem, where delta K is K final minus K initial. So I decided I'm going to use this to solve for average power. Okay, so average power is equal to delta K divided by T, and delta K is Kf minus Ki. What is final kinetic energy? It's half mv squared minus half mu squared divided by T. What is the initial velocity? Initial velocity is equal to 0, so that makes this whole term to be equal to 0. At this point, we're going to substitute 850, sorry about that, velocity 40 squared divided by 10. Therefore, average power is equal to 68,000 watt. Okay, every single answer that we have in this problem has the prefix kilo, so we have to convert or express 68,000 with exponent. So 68 power of 3 watt, which is equivalent to 68 kilowatt. Okay, now we see the answer. The answer is C. Okay, so this is how we solve for average power. Next, we have question number 10. Question number 10, a bullet is fired into a sandbag. The graph of the kinetic energy of the bullet with the bullet's penetration S is shown in the figure 2. The retarding force acting on the bullet during its motion in the sandbag is, okay, this is our goal. We need to figure out the amount of retarding force. So what would the situation look like? We have a sandbag, and I hope that resembles a sandbag. Okay, what do you reckon? Sandbag, then a bullet being fired into it. Okay, so this is the amount of penetration. It penetrates into the sandbag at this depth. Okay, this is 0.15 meter. To find retarding force, I would like to use work done. Work done is equal to Fs cos theta. So this would be my retarding force F. And work done is also equal to delta K. That's what we knew from the previous problem. So Fs cos theta is work done. Delta K is also equal to work done. This is equation number 1. This would be equation number 2. Because this bullet is fired into the sandbag parallel to the motion, or parallel to the object. I mean, the amount of force exerted with the displacement are parallel. That makes Fs cos theta to be equal to Fs. Okay, why is it so? Because Fs cos theta, Fs cos 0 degree, where F and S are pointing in the same direction. So I'll get Fs. Okay. Okay, having done that, I'm going to make some correction to my equation number 1 because I knew that they are parallel. So this one is going to be Fs. So when equation number 1 equate equation number 1 with equation number 2, you'll get Fs equals delta K. So F times displacement is 0.15 divided by delta K, K final minus K initial. K final minus K initial. What is the amount of final kinetic energy when it penetrates into the sandbag? The kinetic energy is equal to 0. So this is K final, this is K initial. When it penetrates into the sandbag, look at the graph. Kinetic energy should be equal to 0. Initial kinetic energy is when it starts to go into the trajectory, when it starts firing into the sandbag. So this is initial kinetic energy, 480. F 0.15. F will then be equal to negative 480 divided by 0.15. Okay, because we are trying to calculate the amount of retarding force, so that's why the answer is negative. Okay, what's your answer? The answer that I got is F equals negative 3200 Newton, which is equivalent to negative 3.2 kilonewton. And my answer would be C. This is the correct answer. Okay, that's all. Thank you.